Hello, everyone. Welcome back to Viessmann Canada Academy's technical training series. It's been a while since we've presented, at least for me anyway. I think Mark was back in November, but we got the band back together again and we're ready to provide you with some interesting information today on the Viessmann Cascade. And we are going to travel back in time here a little bit. So the attempt here on my part was to basically show, as the Cascade Control has been started, the Vitotronic platform, from the start right to the modern control, a lot of the similarities that we have between the setups of those controls. We'll go through some of the connections and you'll see how similar those connections have been, kind of the continuity of those connections. And we'll go through some startups specific to the new boiler controls, figuring that the old systems have already been started up and commissioned. And they are basically more about the curiosity of what those, the makeup of those systems as they're out there. So my target today in doing this was really for plant operators, people that are living in, working in these spaces and curious as to what the connections look like, and, a little bit of information on the controls and the navigation. Technicians that are out there that are servicing these systems and troubleshooting them, understanding what they're looking at when they're standing in front of these controls and their integration into the system. For controls contractors, understanding, when they're looking after that side of it, controlling the building, what the Cascade Control is doing in those particular systems. So a fairly broad scope of people I think we're trying to get to here. And this is really a nuts and bolts type of presentation. So we've done a lot of theory, and I've referenced some different presentations we've done in the past here, which were deeper dives into what I'm talking about or what these controls can do. Because we have an hour or so here, a little, trying to keep it to an hour today. We really want to kind of focus in on just, those connections and some of the preliminary startup information in there. There's definitely deeper subjects to drill into here. And we've provided, or I'm trying to provide as we move through here, some of that information. So if you're interested, you can always look back in our archives on our YouTube channel and grab those documents. Joining me today out of Waterloo, Ontario, he's staying safe in his COVID bubble. Our instructor, the Waterloo Academy, Mark Norris. How are you doing today, Mark?
Good, Scott. How are you?
I'm doing well. It's working.
Yeah,
right on. So we can hear each other.
A crap load of snow here in Ontario, so it's like winter.
Oh, nice. I don't want to complain too much. It's cold here today, but I think we're still above zero. So you get a little spoiled out here on the West Coast.
Yeah, but all those poor guys in the middle of the country, like between BC and Manitoba, man, I feel Northern Ontario, I feel sorry for them.
Well, I figure most of those guys are inside watching this presentation today, so it kind of benefits us, right?
Yeah, that would be good for them.
Yeah, I understand like minus 50 means on a thermometer. I have no idea what that means to the human body. It can't be good. So yeah, I would stay inside.
About this time last year, right before COVID shut us all down, I was in Saskatchewan where it was like minus 42 overnight one night. And I went, this is freaking cold. Why am I here in February?
Yeah, it would make you think about a lot of things. I think that kind of numbing cold for sure.
So we have some ability for you guys to ask questions. There's a questions and answers box on your screen. Use that one. Don't use the chat box, because when we use the chat box, I don't get a full recording of what it is. If you use the Q&A box, I will try to keep up with your questions in real time. And anything I can't answer in real time, we'll spend some time at the end. But anybody who attended today will get the a copy of the Q&A when it's all over. It'll get emailed out to you. So you not only will you get the question, you will also get the answers. And so we want to make sure that you guys get the information. You'll also get a PDF of this presentation in that same email. So you'll have a copy of the slide deck.
Excellent. All right. Thanks, Mark, for looking after the questions and answers. I'm going to just focus in on the presentation. There is quite a bit of material here, so we're going to weave through it. So we'll get started. And the first thing I wanted to jump right in on is we had a presentation Mark did back September 2020 that I borrowed, thank you very much, Mark, some of his slides actually in this presentation talking about the Cascade. But this is one of those presentations I talked about. This, what we're doing today is a complement to what Mark presented back here in September. So the whole idea is to get as much of this information out in different formats for you, little nuggets that you can kind of dip into. If you find something very interesting, like I say, it's always encourage you to go back to these archive presentations. And you can find those on our Viessmann North America YouTube channel. And go through there, and you'll find these presentations all there waiting for your participation. As we move through here, so we're looking at systems and a variety of systems. We're going back, and some of these boilers are discontinued. The CT3 Vitotronic is down here in the bottom corner. We still have the Vitoron 200, but we have a couple of generations of Vitodens 200s here, new and older series, new CA3B boilers and CM2s. And the question, what do these systems all share in common? Obviously, they're heating, domestic hot water and spacing, all that kind of stuff. But if you kind of listen to the start of the presentation, the commonality that we're focusing on today is the Cascade Control. All of these boilers that we saw in that previous slide are all connected to a cascade, and the cascade is doing a specific function in those particular systems that we're going to discover here as we move through. But as we are looking at these different generations of cascades, we're going to focus in on the standard cascades. We're going to stay away from the customized cascades, which are available. Some of the connections will be the same between a custom and a standard cascade system, but some of them are very different. So our focus here, not to confuse, and again, we only have an hour time, is to really hone in on these platforms. So the oldest MW1S type of control, MW2S type of cascade here. The next generation, what we call the block control interface, MW1B, MW2B, which is still used, the speaker control with the Vitoron 200 boilers. And then we moved to touchscreen. So now we've got the MW2C control here, GW6B. And that control has really, the interface has changed over the last year or so. So an upgraded kind of control interface, still touchscreen, et cetera. So our whole idea here is the fluidity of these controls in these systems as we move through. If you want to know what control you're working on, so if some of these controls look familiar to you, I've seen that in my boiler plant. I wonder what the model number is. The information on the controls is always stored in the bottom right-hand corner of that control face here. Sometimes it's covered up by a DIN rail or a little plastic cover here. You remove that, and you'll actually be able to expose the model number of the control interface that you're working with. So the Vitotronic 300, they're all 300 controls for Cascade, but some will have a different nomenclature, MW1, MW2B, GW6B. When we're looking for information, we want to make sure we have the right boiler or control model, as well as anything to do with tech support. So if we're trying to give our tech guys a call and they're looking for that model number, this is the best spot that you'll be able to locate that and give that information. So everybody's talking about the same control as you're moving forward there. This is also the same spot for boiler controls. And some of these are boiler controls and cascade controls, as we'll look through here. They're integrated as both boiler and cascade. But even some of your just standard boiler controls, that information will be in that bottom right-hand corner moving forward in your systems there. So some of these controls are going to be external, as I just mentioned. So there will be, this cascade sitting on the wall somewhere. Sometimes it's sitting on the low loss header manifold in primary, secondary systems. Other times it's going to be, it's going to be integrated into the boilers. So as I mentioned, some of the newer boilers, the Vitotronic 200, CM2s, and the CA3B boilers, the Cascade Control is integrated into the boiler itself. So it acts as the operator of the system, as well as a control for that specific boiler. So it has a dual functionality. Whereas these controls on the top are strictly cascade. So they know they're cascades out of the box, wiring in, they know that they're the cascade, and their function is going to be specific to how you install it. So let's have a look at what these systems kind of look like. So out of the box, these controls, as far as a relationship to the boiler and to your systems as a whole, they are a standalone control, which means that they don't necessarily need to have any type of third-party influence, such as a building automation system or any type of accessory control. We could literally, as far as the spacing side of the system, we can utilize what comes with the control, an outdoor sensor, and typically with heating systems and hot water systems, there's another sensor we're going to install there for this Cascade to pick up a specific temperature that it's looking for. And with this information, we can now program outdoor reset strategy for our heating system. So this stuff over here can all be scheduled based on the temperature outside today. So it'll be a very different temperature, as Mark and I just talked about. If we had this Cascade Control heating our system in Vancouver, that'd be very different today than it would be in Edmonton right now. So very different based on that outdoor temperature that we're dealing with there. So that's the possibility. The picture that we just looked at there was primary, secondary piping. So, you know, the sensor is usually, in our systems, usually there's a well that's in the low loss header that we can plug that sensor in. We call it a common supply sensor, low loss header sensor sometimes. Common supply is for when it's not primary, secondary, and that's where this little picture is going to. So when we're putting that sensor in our systems here, it's important that that is going to pick up the temperature of both boiler supplies. So we see that we don't want that where it's not going to pick up the temperature of that boiler. We want to make sure these sensors are picking up what we call a common supply. So any one of the boilers in that system is operating, this sensor needs to pick up that temperature and feed that back to control. Otherwise, it's going to start pulling another boiler on when it may not need it, and that becomes inefficient, and of course, you're going to have some system problems. So important to make sure that those sensors are located in the right spot. In primary, secondary, it's fairly simple. Often that secondary supply outlet's good. On a common supply here, we have to make sure that we've got an area where that's going to plug in to pick up those temperatures effectively. We can also add, for our heating system, other temperature controls. So we have accessories that can be added to our Cascade, mixing valve kits here. So the mixing valve, as well as the actuator for the mixing valve and a supply sensor. And we can wire those pumps directly off of our Cascade, off the line voltage. These are all 120 volt pumps, no greater than 2 amps. If we need a higher rated amperage, or it's a different voltage connection on that circulator, then we can use a contactor to switch off of the control and feed our power from a different source, so we don't overamp the circuit on the Cascade Control. We can also wire in the mixing valves now, and these are 120 volt or 24 volt floating. We have the ability of doing either or both in a system. So you could have 124 volt floating and one 120 volt floating mixing valve if needed. And those be wired back to the control as well. And the sensors. So for every temperature we're looking to pick up here, we need a sensor to make sure that the feedback to the Cascade to let it know that we're at temperature, or we need to open that mixing valve a little bit more. So for our heating system, what we have here is a sensor picking up the temperature being fed to this circuit here without a mixing valve. And then we have sensors being fed back to the Cascade that are picking up the temperatures coming out for the second and third mixing valve. So 3 different temperatures working off of the outdoor temperature sensor. You also have the ability of auxiliary loads, and what we mean by that are, you know, possibly things like pool heating or snow melt or some other, you know, car wash, things that are going to use, you know, need something heated up, whether it's water or space. And it doesn't necessarily need to have a operation off of the outdoor sensor. We can use a dry contact to these controls, just close a contact, and now that Cascade Control is picking up another temperature that it needs to feed this auxiliary load over here. We can also use and/or type of application where we can float a signal using 0 to 10 volt DC. So some of these would require other accessories. We're going to look at how to connect those in a little bit. So we'll come back to this information just to know that we have the ability of adding that to the Cascade. And sometimes, like I say, our building automation system will use these particular connections as well for operating the Cascade directly. So maybe we're not using the Cascade outdoor reset, and the BMS system is just giving us a signal from a dry contact or 0 to 10. So we'll look at that as well as we move through. Those are fairly important contacts when it comes to Cascades, and worthy of good review. The other area that the Cascade can look at is if we plug in a sensor. We always use a sensor on our boilers for on our boiler controls for or system controls for domestic hot water. We plug that sensor in. When you power that control up, it knows right away it has domestic hot water. It's going to give you a pump output now dedicated for domestic hot water tank heating. Again, a 120 volt, 2 amp pump, no greater than. Otherwise, you can use a contactor on it. And now in conjunction with this, there's a built-in priority logic that's programmed that when the domestic is calling, you adjust your set point, the tank is actually requesting heat right now, it will actually shut down the other side of the system. So everything is now dedicated to heating that domestic hot water, keeping that recovery as high as it possibly can. Those are programmable. You can have those as priority, or you can basically take the priority out. If you have mixing valves, you also have the ability, if you like, what we call kind of load-based priority. So the Cascade Control is intelligent enough. It looks at the situation, what the load is on the domestic, what the day is like out. And if it can crack those mixing valves and turn the pump on, it's going to do so. Maybe they're not operating at full capacity while they're doing domestic. Maybe it's only 30% of the capacity, but those systems are basically gives you some flexibility there to keep the heat on without sacrificing any domestic hot water capability. So this is kind of how that Cascade Control was built in this type of a capacity where it can essentially take your whole building and operate it via outdoor reset, some fixed temperature capabilities, as well as domestic hot water production. The other flip side of this would be basically a building automation system, a BMS control. So the system, the building system here, all of the heating side of it, mixing valves, pumps, your domestic hot water, everything here is controlled off of our BMS control. It does all the calculations of what it needs for temperature. Through the gateway, you can either control company can either just program in and write a set point to the Cascade directly. It can use the 0 to 10 volt input modules we're going to talk about here shortly, and basically send us send the Cascade a control floating 0 to 10. It can just close a contact, dry contact for fixed set point. It can give the Cascade Control set point for its desired temperature to heat this particular building at that particular point in time. And the Cascade looks after its part of the building system, and that is the boilers. So it still has the ability of turning the boilers on, turning the boilers off, and giving the set point based on whatever it's getting from the BMS system here. So these systems typically have very little connections to the Cascade. Basically, your Cascade Control, if you open it up, all the pumps, all the mixing valves, all that, and sensors are basically connected to your BMS system. The Cascade would have its power, its communication cables for communication to the controls that it's functioning within, as well as some of those sensors we talked about. Maybe the boiler, the common supply sensor would be connected in that particular capacity. So limited wiring when it comes to being integrated with BMS if the BMS is looking after the whole system here. Important that sensor connection now. So if we have a Cascade that's looking for a temperature that it's been given to by the BMS, if those sensors are in different locations, of course, they're not going to read the same temperature at the same time, and that can cause some confusion and some problems, and then phone calls because there's issues with, the system is looking for this and we're not getting to that particular point. You bring those sensors a little closer together, all of a sudden things start to clear out a little bit. So the location of both sensors should be in relative proximity to each other, and not after T's and stuff like that, where some of that load is being pulled off. We might see some temperature differentials at that point. So a common spot for both sensors would be desirable at that point to make sure that we're reading and getting the right spot on our controls, getting that right temperature. So back to this little drawing, and again, this is generic. All the Cascades we're going to talk about are able to do what we just talked about. When the control gets a temperature, so as far as functioning, so whether it was BMS or whether it was a temperature feedback from different areas of the building like we're seeing here, this is how the Cascade is going to react. It's going to look at the temperatures that has been given. it's going to select the highest temperature, and that's the one it's going to target. In this case, it's going to target that where the sensor is located here. It wants to see that temperature 135 at this particular point in time, at this spot right here on the common supply sensor. And it's going to use its ability to operate these boilers to achieve that particular target. And some of the different methods that the control is going to do that will be based on the type of staging strategy that we've looked at. And that's going to be something we program into the control on startup. We'll have a look at what that means. And of course, you know, the operation of the building is dependent on what that temperature that we're looking for here. So the communication between the cascade and the boilers, you can see it in the outline here in blue. All these boilers are connected back to the cascade here. And of course, as it's trying to reach that particular set point, it's going to bring on those boilers. And again, depending on the strategy that we're using, it can maximize all of its boiler capacity here to reach that particular temperature if it has to. And then once that temperature set point's manageable, we're getting close to hitting our temperature here. And anticipation is we could overshoot that temperature. We don't start turning boilers off and reducing that set point. The cascade can do that until that set point is met. And then of course that final boiler shuts off and we've managed to meet our set point. The temperature drops back down again based on the differential that we are, that's logic that's in the control that is programmable. It will start these systems back up again and operate again. But the whole idea there is to operate the system as efficiently as possible. And that really depends on that strategy that you're utilizing for your system. Some of the other things it can do with that now, based on these boilers' operating times, it gets information on how many hours these boilers have been running. So based on the runtime, you can program. This is not programmed by default, but you can get in and program whether it's 1 day a month. The control looks at the operating hours and starts rotating the boilers, or based on a certain amount of run hours achieved, we'll start rotating the units. In this case, we look at basically at one spot here a month. I think it's the first Monday of the month. It looks at it, sees that this boiler here, number 3, is only 190 hours. It's going to select this as a new lead. And of course, our number 1 boiler here with 250 will now be the last boiler. So essentially, it'll rotate those and try to get the equal runtime on your boilers without having to manually go in there and rotate these on a monthly basis, which is still possible. You can do manual rotation, but we've got this ability to do this automatically within the control. On the other side of it, as far as a control, this is also a manager. So it manages your heating system here as well. If we had some sort of an issue where one of the boilers for some reason wasn't able to operate, that information is fed back directly on our connections here, communication, and the boiler is going to say it's not available. And the cascade is also going to pick up that fault. And you're going to see a little red light on the cascade as well to tell you that it's basically identified a problem with this boiler, and it wants to make sure that if there's any BMS connection, if there's any audible alarms or visual alarms that are on the cascade that have been wired, that gets those basically relay that information to somebody that there's a problem in the boiler room that needs to be addressed. As far as the cascade goes, it's going to switch that to another boiler if it has to make sure that we maintain the temperatures that we need in our system. So it's going to go through whatever lengths it has to ensure that the temperature is maintained in the heating system, even though we're down in one of our boilers as far as its capacity. As far as the boiler operation, so that's kind of the cascade system, how it basically looks at the system, whether it's standalone or in a building, in part of an integrated building system. When we're looking at the boilers, really nothing changes on the boilers as far as what it has to do. It gets the set point from the cascade, but all of its safeties are still intact. So if there's an issue on the safety side, that's going to block the boiler from operating. It's not going to operate outside of that comfort zone. It's not going to be basically unsafe. It has to basically modulate, so it does its own modulation based on its operation. It doesn't want to hit the set point too quickly, so typically it uses an integral there to logic to ensure that it stays in a good run cycle. It will not increase its temperature. So if the temperature from the cascade exceeds what the maximum boiler temperature of that unit is, that particular appliance, that boiler is just going to essentially hit its maximum, and that's it. So again, the boiler itself looks after its own internal safeties. None of that changes. It's effectively just getting a set point from a control, and it operates within its own safe capacity to get to that particular operation, independent of the boiler we're talking about here. They all have that same logic. So we get to the displays of these particular cascades. So we're going back in time here a little bit, and you can see here we've got the oldest of the cascades here. The screen looks a little bit different. You got lots of buttons on this one here. So the control interface here was really, each button had a specific purpose. When we changed from this type of platform interface, we moved to the control over here, the MW1B, MW2B, and we went from kind of the buttons that had specific functions to a text-based operation and limited the buttons. So basically navigation keys, menu keys, versus every button has a specific function. Then we moved to the bottom two controls here over the last number of years, and it's now a touchscreen control versus the buttons here on the side. So everything's now on a touchscreen interface. And essentially the difference between these two controls really is the display. So everything, a lot of the navigation is identical. It's just essentially the display is a little nicer look to it, a little bit more in depth, detail as far as the digital display is on that particular control. But let's have a peek at the similarities of what these controls were giving us. So for people that have this particular control that you've been working with, the boiler sequence is right here in front of you on the control, and these little dashes have some fairly important purposes if we start moving through. So the boiler sequence here is 1 and 2. You can see that. When the boiler starts moving ahead of both dashes, we know this boiler number 2 is actually running. So it'll be on, it'll be firing, and you can verify that when you walk in the boiler room. It should be in operation. Whereas boiler number 1 is still waiting. It's in standby. It's ready to fire if the cascade needs it. So it's there prepared to fire. Now, if you have a boiler that's behind both dashes here, we see it now, the one is back here, that boiler is now offline. The cascade is not able to open and pull that boiler on. So it might just be somebody powered it off, maybe to service it. They might have put it in the standby or frost protection. In this case, it looks like it has a fault because we see the fault light actually came up on the cascade, tell us that there's a communication fault with this particular boiler number 1. We also see a day of the week here. So Monday, or you see Tuesday, Wednesday, Thursday. So there's Monday is the day of the week here. And there's our extended menu. And as I mentioned, all these controls have an extended menu for things like service and coding and different programming things you need to get into. This control, basically the extended menu is if you were looking for things like adjusting your domestic hot water temperature, you went to the little thermometer with the faucet here, you pushed that, you made your adjustments and pushed OK. Your slope and your shift for your heating curves were all right here, dedicated buttons. Timer programs with clocks always symbolize timer programs. So the radiator with a timer clock was your space heating timer. Domestic timers were all part of these controls even back in the day there. Your navigation up and plus and minus, and your OK button to write the information into your control. And with these controls, you could also push multiple buttons and you'd be able to get into different areas of the control. So if I wanted to get into coding, I would push and hold down. Coding 1 would be the standby and the tap button here. Push those 2 buttons down, and of course I get into coding 1. Coding 2 would be the 2 outer buttons here, these 2 buttons right here, the 2 tap buttons basically for coding level 2. Relay test, OK, and standby. So you get an idea that even though it's an older control, there's still a lot of functionality in that control, as long as you know where to navigate and how to basically find those things. With the MW1, MW2B control that we look at here now, again, there's a lot of the same information, but the interface looks quite a bit different. So let's have a look at what we're dealing with here. Boiler sequence is on the control. This one here, or 3 is the first boiler, 2, 4, and 1 would be the next, basically how these would stage. Whether they're running, waiting, or offline, you can see that here to a degree. The first one here is it's just a little lighter, a little more highlighted. Number 1 is on. 2 and 4 are basically in standby. They're waiting to fire. And of course, if you see the X on that below the number on the boiler, that boiler is offline, whether it's faulting or powered off. It's just not available for the Cascade to fire it. So that's where you're going to get that particular symbol. The common supply temperature, lowest header temperature, is displayed on the bottom right-hand corner. Something new, so we didn't see that on the older control. Now we see a temperature that an actual temperature of the system. A fault will show up on the control screen here, and a little symbol here will indicate that there's a fault for you to have a look at. And of course, the extended menu is accessed with the bottom button here, our little menu key on these little HO1 controls. That we see both on boilers as well as Cascade controls. Now we're moving up to the more current Cascade, a little bit more interactive type of screen here. You know, boilers look a little bit more like boilers in here. A lot more information. So again, your rotation, your basically how your boilers are sequenced are shown right here. This one here is they're all in order right now, but eventually those numbers will start to flip-flop as the run times are adjusted and people start to rotate the units. Whether the boiler is in running operation or it's waiting or it's in standby, sorry, or if it's in fault or off, not available. If it's highlighted here, those boilers are firing. Off, but in standby, just darkened out circle. X in the circle means that those boilers are not available. And we have the common supply temperature, and we also have the set point temperature here. So now we don't just have that supply temperature anymore. We actually have the set point we're targeting as well. So more information on the control screen that we can see. When burners are firing here, this little window gives us a kind of an eye view of the percentage of modulation. So a full window here would mean that we're in full output. A partially loaded window here means we're at some percentage of output. And of course, the input of the boiler is in BTUs or in kilowatts, depending on the units you selected, would be displayed down below. So you're getting some good information there that wasn't available in the other controls. If the fault is shown up, the little triangle will operate. Time and date up in the top right-hand corner here. And of course, extended menu, we push the touchscreen here now for menu up on the top. And the most recent control, you're going to see your boiler sequence in the top of the devices here. Your much more distinctive symbols of what the boilers are looking like in that particular system. So whether they're on, off, or not offline, or if they're in fault, you actually get a definition between which one is in fault or just offline here as well. You'll see your low loss header actual temperature or common supply temperature right there, your set point as well, your input in kilowatts or BTUs, as well as that modulation on the little bars here, a little bit more defined now with like a 30%, 30% windows there for you to get a little bit more accuracy in what your outputs are. Time and date. And of course, if there's a fault, it shows up on that particular screen. And the extended menu is the top right, just like the previous control, just a little bit of a different look to it as we move through. So we're going to get into connections on these boilers. And this is kind of where a lot of similarities are going to be. As a matter of fact, a lot of what I show you here is going to be in the oldest of the 4 Cascades that you're looking at here. But when we're setting up the communication between the boilers and the Cascade, we have to make sure that that communication is done cleanly, that there's no issues with it, that we plug them in correctly. And depending on the type of boilers, there might be some polarity to those connections. All the controls we talk about can work off of LAN communication interfaces. You can see some examples of those in the units below us here. So there's a Vitodens boiler with a LAN card connected into it. Here's a standard Cascade control with its LAN card connected in here. When we get to Vitodens 200, it's a special boiler in the fact that it can also operate with KMK instead of the LAN card here. So that's the only boiler that you can use swap KMK interfaces for lawn communication interface and operate off of the KMK or Viessmann's CAN bus communication network. So it's a little bit of a different setup. We're going to move through that again only for Vitodens. So we're not going to use KMK in a CM2 or a Vitron 200 or a CU3A. So all those are basically all going to be lawn as far as their connections. So how many lawn cards are we going to typically have? And again, these are installed in the field. So you're going to be plugging these into some controls, but you need to know how many you should have. So it depends on the type of setup. So if it's an integrated control, like we see down here in the bottom, those basically you only need 3 modules because you have an integrated Cascade lead boiler control and 2 lag controls here on the CU3 or CA3 boiler. When we have an external Cascade, we have to have a lawn card in it as well as 1 for each boiler. So it's going to be, number of boilers plus Cascade to get your proper number of lawn modules. The location of those modules is plugged in here on the Vitodens boiler on the left-hand side when you tilt the control console down. So regardless of WB2B or B2H boiler, and you're doing a system with lawn, it goes in on this side here. The KMK card, which is actually displayed here, is also connected in the exact same spot if we're doing KMK instead of lawn. We're going to go through that here in a second, though, for all the wiring connections. Your Vitodens B2H series control looks like this. We're going to have to program it for this type of operation. So a standalone, turn it from standalone to multi-boiler. And that control will look something like this. We're going to go through that here in a little bit when we go through the setup. And the previous control, the WB2B control on the Vitodens look like this, and we would have to get into this and program it for that multi-boiler system as well. We're going to show you how to do that here in a moment. Once we get to the CU3A here, you'll see that instead of flipping the control console down, we have to lift a couple of covers off of the top of the boiler, and that lawn card is sitting on the same spot as the Vitodens. Actually, the same control console, really, just in a different spot. On the CM2 boiler or CU3A boiler, and the lawn card is plugged in on the left-hand side of that as well. So we'll take these covers off, you'll see that little lawn card sitting right in there, and there it is. With the other controls, whether they're boiler controls, integrated control boiler and Cascade, or the boiler controls, and you're plugging the lawn cards in, they are in the same spot. So we can, doesn't matter what control here I profiled for you, that lawn card is going to plug right into the exact same connection here on the control interface. So whether it's a CA3, we got a Vitron 200 using a GC1B control, or an old CT3 on a GC1 control here, that lawn card went in the exact same spot. There it is, standing nice and proud up in vertical here, and plugged into that little slot that connects it to the main circuit board in the control itself. Important things about lawn. No lawn port is to be left open. We do have what we call end-of-line resistors. You see those depicted here in EOL. Any open ports, a resistor should be plugged in there. These specific resistors plugged in there just to close the door so that you don't have any echoing or any backfeeding noise to the Cascade that could cause some communication issues. So we always like to close those ports off, as we see here. When we're wiring these controls, like I say, you got your Cascade over here. We got 2 boiler controls sitting up here. We're going to plug those lawn modules in. They go in the exact same spot on both of these. We slide them in the little, it has a little slot that a little track that they're going to slide in. We're going to plug them in. We're going to make our RJ45 connection here, Ethernet cable, the connection, Cat5, typical wire cable is used. And we plug those into the lawn ports. So there's the ports, and there's no in or out here. You can reverse these. It doesn't matter to the lawn communication how these are connected, as long as they're connected. And of course, we still have these 2 open ports. So we've gone from this control, daisy chain, and plugged into this control. Now daisy chain and over to the Cascade. We want to close these 2 ports off. So we put our little end-of-line resistors in there. And now we basically have that system set up. I always like to recommend that so once you finish those connections, if you're doing that, push the lawn cards a little gently, push them back in just to make sure they haven't come unseated so that you have good communication there. Of course, what we want to see are those little lights flashing on the lawn cards. That's usually a good signal that we've got our communications established. So a little light flashing there is always a good thing to see. If we were doing something like just to check those communication connections, there is a function in all of the controls. And this is the oldest of the controls. If I push the OK button down and the faucet button down, you see my fingers there, hold them down for a few minutes, it's going to go into a lawn or participant check. And this one here, you can see a little on the screen here, participant check for number 2 participant. So when I do that, the actual boiler control you can see will flash, indicating that it's actually getting some sort of communication. And coming back on the control is check OK. So it looks like that communication between this boiler number 2 and participant number 2 is good to go. If I am looking at another boiler and there's an issue, so this one here is the number 1 boiler. It's got a fault on it, little red lights on it. I do a check here for a participant, and I'm going to come back with check not OK. So that tells me that there's something wrong with the communication between these 2 devices. And in this case, it's a fault. So once I fix that particular fault, that boiler will be able to run. And now I would go back to the check and it would be OK again. But right now, my Cascade Control is picking up that there's a fault with boiler number 1, and you see that boiler is stuck in back of the 2 dashes. On the newer controls, if I want to do a participant check, very simple to do. First thing you're going to do is push the extended menu key. From there, we're going to go to the main menu. You're going to push this little arrow key, and then there'll be service. Basically, this menu has got a couple of extra icons on it. You push this little arrow key, and you're going to see service pop up. You push on the service. It's going to ask you for a password. So VI service for the older controls. For this particular type of control, it would be VI expert would work. And from there, we get into the service menu, and we're looking for service functions. So you click on the service functions here, and then we've got lawn subscriber check right here. So it'll do the exact same thing. You scroll through the different subscribers or participants in your system, and each one of those you can check to make sure that that communication has been established and it's all good to go. Very simple to do. So some examples of those systems. I mean, we got an 8 boiler system here, 8 CU3As, so anywhere from 2 to 8 boilers on a CU3A system. You got CM2 units. Again, it's an integrated control here, so you don't see that external control, it's integrated. So this is the lead and Cascade, and these other 7 boilers are going to be lag boilers programmed, and interline resistors in there. Our external Cascade and 8 participants here, 8 Vitodens in this particular point that we're looking at. So these controls can all do up to 8 boilers, anywhere from 2 to 8. And even in the CA3 units, now this will require a little bit of field adjustment, but typically a standalone CA3, you have no adjustments to program the lead, Cascade, and the lag that's already done for you. But when you get into this type of system where you're putting multiple CA3s together, this boiler here, you wouldn't have to do anything to. But this guy, you're gonna have to reprogram this lag boiler number 4, number 5, number 6, and number 7 and number 8. We just have to be renumbered again. So we got to take this was usually the Cascade for this particular boiler. It's gonna now be reprogrammed as a lag. Same with this unit number 7. It used to be number 1, number 2 in standalone, but now it's gonna be number 7, number 8. So you would have to do some reprogramming as well as connection of the LAN between those particular units to make sure we established a system here. So just a little extra work there in the field for those units. When you're dealing with KMK, so kind of flashing back to the Vitodens 200 boiler, and this didn't matter if it was a WB2B, so the older unit, or the new B2 series of boilers. Again, only specific to those units, we could add, instead of LAN, we could use KMK. No card required for the Cascade. It uses a communication port that's already on the Cascade control. So this is polarity sensitive though, the KMK card. So you notice that when we're using KMK, it's like twisted pair 16 gauge wire would be something that we would look at for this type of connection. Then we come in on the boilers on 3 and 4. We go out to the next boiler or to the Cascade on 1 and 2. So in on 3 and 4, out on 1 and 2 would be how we would wire this and make sure we get those connections correct as we look at the manual. And then going to that Cascade, we have a 145 plug. And on our Cascade control, what we're looking for, it's going to plug into a terminal, which is right beside that LAN connection we just talked about. So right here, these little pink plug ports, a 145 plug would plug in there. And now that's how we set up communication between the Cascade and the Vitodens line of boilers using the KMK card. So a little less programming when we use KMK. We don't have to worry about law and participant numbers. It's just boiler numbers when we're setting it up. But again, another effective way of communication between the Cascade and these particular boilers that we have available for you to utilize. All right. So we're getting into some of the other connections. So that was just literally how we connect the boilers to the Cascade. What about some of these other things we talked about? We have 0 to 10 volt input. So if we wanted to use a floating signal, say we have a BMS system and we want to communicate our set points this way, so we can change those or adjust them as the load increases and decreases, then we can use the 0 to 10 volt. We use two different modules though. So the previous generations of controls used a 0 to 10 volt input module, it was called. The newer generations, touchscreens, and the NW1 and 2B use the EA1 module. And this has effectively the ability of doing 0 to 10, and we're going to see as well, it has the inputs for dry contacts for things like external blocking, external heat demand, and stuff like that. These are a little bit more desirable in the new controls because you can actually pick up these contacts when they're closed on your operating status. So it's a little bit easier for your BMS guy to see when contacts are closed versus open. A little less so when we look at the other option as we go through the next slide here coming up. So two different controls, different generations of platforms or different generations of Cascades we're going to use these on, but the same type of wiring, the same type of logic as far as the operation. So if we think about this, the building operation operator is going to give us a signal, and all we're doing is taking that signal and converting it to a set point. And this is the little graph here on the left-hand side. And if you think about the signal as a lineal, so if we have a 3 volt signal, we're going to 30C. 6 volt signal, we're going to 60C. 8 volt signal, we go to 80C. 10 volt signal, we go to 100C. Now, the issue with that, this temperature would be limited by whatever that boiler operating capacity is. Some boilers cannot reach much past 80C. So some of the smaller Vitodens boilers are not going to give you 100C. Whereas if you're operating off of a CM2 boiler, you might be able to get close to that 100C as far as an operation, probably close to about 95C, about 9.5 volts. But in saying that, then if I give basically a 10 volt signal in a building automation system and I have a bank of Vitodens, I'm not going to reach 100C. It's always limited by what that boiler can do. All right. As far as the wiring goes, again, we're looking at these little pink plugs inside of your Cascade controls, and all of these Cascades have these little pink connections. The 0 to 10 volt input module, the previous model, our 0 to 10 from building management would go to the 144 plug. On the EA1 module here, it goes on the 1 and 2 ports of the 0 to 10 volt input plug here. It's a little orange plug. And it's polarity sensitive, so make sure that you have the polarity correct on those connections. And then from the modules, we go to, we're going to go to the 145 connection. So 145 on both of these accessories directly into the 145 connection at the Cascade Control. Now these, you got 2 ports here, so if one's being used, use the other one. You can also parallel your connections here. So they don't have to be just clean, just I can only have 2 wires in there. You can bundle it like end switches into a 145 connection, and the Cascade can sort that particular information out as far as what it's communicating with on that. It's just a communication protocol. So as long as everything's basically wired back to the Cascade, it can figure that information out. Now, as I mentioned, these dry contacts on the EA1 module, we just saw that module using the 0 to 10 volt aspect of it, but it also has 3 dry contacts you can use for things like blocking, external heat demand. Each one of these contacts is programmable for one function. So we can have up to 3 different functions using these little DE1, DE2 contacts. So they're all programmable in coding level 2 for things like external demand. We want to fix temperature set point, or close a contact here on DE2 to block the system from operation remotely, effectively shutting the whole system down until you open that contact again. So those are available. These 143 and 146 plugs are also available on every control, not as an accessory, but standard. And again, doesn't matter what Cascade you see here, they all have the 143 and the 146 plugs connected here. The difference is when these ones close, you don't actually see that in the status. So the EA1 module is nicer, that I can see that DE1 contact is closed. That's why the boilers aren't starting, that type of information. So a little bit more more communication using the EA1 module on the modern controls than using these 143, 146 plugs. But if we wanted to use these, they're available. The 143 plug here, if we close that contact on 2 and 3, that is basically going to, and program blocking, we are going to block this system now from operation until we open that contact up. So it doesn't matter what the temperature is outside, the building's freezing up and you're jamming a set point to that control, if you've closed this contact, this thing is in disable. So it needs to be open for that boiler to start firing up again. So remember that with that, it's fairly powerful connection here, that little dry contact, it'll shut your whole system down. On the 146 connection, we close that contact there. And now we can program an external demand temperature. So a fixed temperature when we want the boiler to fire up to that, we just close the contact and we program that number here at 9B. That's why I keep circling around this little 9B here. That's where we would program in the set point. That's the same address that we program in external heat demand temperature for the EA1 modules as well on our Cascades. So there's your 0 to 10 volt. There's your dry contact connections and what they'll do for you. When we're connecting our outside world to our Viessmann world here, we typically interface with your building management system via a gateway. So depending on the age of the control, it could be Vitotronic or it could be a Vitogate 300. The Vitogate 300 is the one on the bottom here. It came in a different type of format. The Vitogate 300 looks like this. It could be in a metal enclosure. You could take it out of the enclosure and wire it directly on the DIN rail of your system or one of your boilers there, one that's the Cascade, for instance. But as far as the wiring connections, they'll all still be the same regardless of where they're plugged in. The difference between these two basically is the Vitotronic. You would have to know, what type of platform your building management system was operating off of. Versus the Vitogate 300, that's programmable. So it's one control here, and as we were programming it, we're going to select which we're going to use. And of course, the control has multiple software and just basically picks that up and runs with whatever platform you're using. The connections, basically, again, we're in the lawn cards of the Cascade. You plug your RJ45 connection, your Ethernet cable into the lawn card. And on the Vitogate 300, pictured here on the left, and there's a schematic, more full schematic of the Vitotronic. We've got long connections here, and that's going to basically plug in from one of these connections into your Cascade control. Just had a little bit of a mind blank there. And on the Vitotronic, we have the same thing, a long connection, and of course that plugs in the exact same spot in one of the long cards inside your Cascade here. And of course, the LAN connection here was for your controls contractor to link his system into this system here to his laptop so he could do his setup and his operation. So that's the basic connection there. In order to get more information, and I encourage you to have a look at this one if you're in this particular world. Mark did an excellent presentation about 2 months ago here now, 3 months ago. Time flies, Mark. And it's archived now, but lots of great information on these particular gateways. And he even goes through a simulation on some of that information there as well. So this one's archived again on the YouTube channel. If you were interested, you can certainly have a look at that one moving forward. As far as the schematics go, so as far as all the little connections here between your pumps, mixing valves, all that kind of stuff, basically we have some rather large drawings that come with all the controls that give you specifics of where those pumps and where those sensors are to be wired. And following this, connection will guarantee that you hit the right spot on these sensors that you're looking at as far as your system. So some of these controls look fairly sophisticated here. You get every connection that you need on these schematics and where they go. If it's a boiler control, like this one here is, you can see it actually has the damper for common venting connected to it, as well as a low gas pressure switch, low water cutoff. So very detailed here. The burner control up here on the right-hand side. But easy to read and easy to follow along. So you know where each mixing valve is supposed to go for heating, all the pumps where they're supposed to go. If there's an alarm output, the boiler isolation valve sitting right there, all the sensor inputs that would be needed to operate the different pumps and different mixing valves you have here, where they're supposed to go, highly detailed in these controls. We go all the ways back with this wiring guide, all the ways back to the earliest of the controls. So how to wire the old MW1S control is included in this document here as well. So this is always accessible, whether it's a 10-year-old system or it's a 10-minute system. We have that documentation available for you in this particular type of platform. My recommendation on these is divide and conquer. Literally, is the sensors typically go into the Cascade Control proper. So we open up the Cascade Control and you'll see all the slots where we plug in these little connections. We just talked about the 145 connections, for instance. Of course, your long connections up in there. Your sensors are all lined up here. 143 plugs sitting right here. All the line voltage stuff is coming off of this DIN rail. And the DIN rail is typically sitting below the Cascade if it's an external Cascade. If it's on a boiler, if it's on a CM2, for instance, that DIN rail is going to be in the back of the boiler. The controls on the front of the boiler. And there's basically the wiring here. It goes through a channel from front to back to front. So we plug in everything from here into the Cascade, but still the same kind of wiring. All your line voltage outputs are here. And on a CA3 boiler, you've got the display is right out in the front, and of course the control itself is inside of the enclosure of that particular boiler. So a little bit of a different setup where the DIN rail is located in those units, but the same kind of concept. The DIN rail is where all of that field line voltage output stuff is going to come from. Sensors plug right into the control proper. So when we're getting into the startup of these boilers, we look at it as far as starting up. As soon as you power up a Cascade Control, the modern controls, it's going to pop up a little wizard here, which makes basically everything that you need to program to start that system is in this area. There will be other details you might, depending on the system and, things if you're using the DE contacts, for instance, for, special programming of remote disables and stuff like that, then there will be some auxiliary coding you'd have to adjust. But as far as setting up that Cascade, as soon as you start it up, this is kind of the screen you get. And it's going to prompt you a couple of questions. This is an integrated control, which means it's sitting on a boiler, so a CM2 or a CA3 boiler. And when you power these controls up and you do the programming, it asks you right here, application, because you're going to tell that particular control it's the lead Cascade or it's the lag boiler. And this is where you're going to do it right here. We look at the external Cascade controls. They don't have that application because they know they're a Cascade control. It's how they're defined, and you're just going to set up the language, date, time, and measuring units for that particular system. So language on both controls, when you push the button, it's going to take you to the screen here. You select the language that you like, you want to interface with. Your date and time, you push the button there and it comes up with the date. You push the button and you select your date and the calendar month, and the time can be a 24 or a 12-hour clock. The importance of the date and time basically is if you are looking at faults, you want to time and date stamp your faults accurately. You want to make sure this is accurate. If you're using heating timer programs, so you're using outdoor reset, you're doing any setback times, you want to make sure these are accurate as well, so that your timer is accurate on your control. Same with domestic hot water timing and stuff. We'll look at that, how to set those up here in a minute. Measuring units, it's pretty straightforward, depending on what you like to read, metric or imperial. You have those selections. So now you select the metric, everything being Celsius and kilowatts, Fahrenheit, and BTUs for imperial. And of course, that one extra step on the boilers that are integrated into as a boiler control, you're going to select that cascade for one of those units and the lead, and then you're going to have the lag boiler will be the other boilers in that particular system. So the same process for each one of those boilers in that particular system. So other adjustments that are going to be made, and once you finish that portion of the startup, it's going to ask you, the control, if you want to make any more additional changes. And when you say yes, it's going to ask you how many boilers. So you're going to input that. That's usually in coding, but it pulls that information right to the front. And two or more, some cascades are only capable of up to 4. So the Vitodens 200 system is only a 4 boiler cascade, whereas some are up to 8. So you just tell it how many boilers this system should be looking for, and now it's going to display just the number of boilers that you have in that particular site. Some other information that's going to be asked is what type of scheme or what type of venting is adapted to the control. So now these are specific to more modern controls. You're not going to see this in the earliest of the cascades because there wasn't common venting back then. But now, based on the control logic here, the cascade, we want to program in whether it's a common vent system or not a common vented system, because it's going to be looking for specific switches to open and close for proper operation when we have a common vented versus non-common vent system. So that's part of the programming of your cascade as well, is what type of vent configuration. And back to this, I mentioned this earlier, we're talking about how the cascade will stage your boilers. There are different strategies. So a different strategy for condensing versus non-condensing boilers. Typically non-condensing, you're going to turn a boiler on, it's going to fire up to its full output, and then that second boiler is going to kick in, or somewhere in that particular vicinity. It might drop the other burner down when that second boiler comes on. But in a condensing system, an application, you could see all of the boilers in that system on, but at low fire. So the whole idea there is to maximize the condensing aspect of your boiler by using the condensing strategy. So it depends on what you've used there. That's going to really impact how that system operates. So it's going to ask you that question. In the older legacy control, so there's our older unit with the LCD display here and the big extended menu with all the buttons. You had to access programming out of coding level 2. So you had to physically go into coding level 2, and then you would set all those parameters by going through the different options that you had to look for, number of boilers and condensing strategy, etc. You had to hold down the faucet and the faucet rad button here, and that would get you into coding level 2. On the MW1, MW2B control, as you see here, this control, we would be able to access the service level first by pressing the OK and the menu key. And then from there, we would get the service screen that would pop up. We would want to go to coding level 2, OK, and the top button here, OK and back, will now get us into coding level 2. And the same thing, we're going to program in there the number of boilers and all the other information that we're looking for. The boiler controls, now that you got your cascades all set up there, would also need to have some programming to make sure that they're going to relate or communicate with that boiler. And what we're looking for there is basically these guys on the left. You would have programmed those the same way you set up the cascade. Remember, the little wizard will come up, and you're going to have to tell that control based on, that you're a lag boiler. I already got a lead in cascade, so you're going to be a lag, and you're number 2. This one here, we set up in lag, although it looks like it says it's the number 1 boiler, but it's going to be basically, from 2 to 8, whatever that might one be. So that's the same wizard is used to set up the lag control on these particular boilers as we did for the cascade. When we're looking at the Vitodens 200 control, we press and hold the OK and the menu key. And that's basically hold it down until the service screen pops up. We scroll down to service functions. And then from there, we scroll down to multiple boiler system, check the box here and say yes. The control shuts down, and then it basically reroutes the software for the multi-boiler. And now your screen looks something like this. And now we've got to go in, and we still have to program in the boiler number and all that kind of stuff. But now you've got it basically that it knows it's part of a cascade system. These three controls here, the older GC1, GC1B, and of course the control that was on the Vitodens WB2B, HC1B, I think it was called. That control you had to program in coding level 2. So we had to get into coding level 1 or 2. We're going to show you how to get into 1 because you don't really need a whole lot of coding information. It's pretty simple in coding 1 to adjust these controls in the field. So we'll have a look at these controls. There's one extra address that you'd have to add for programming of these three controls that you're going to see here in a second. So to get into the service menu to basically allocate the boiler number and the participant number on these boiler controls, we have to access the menu key here first, hold that down. That gets you into the main menu. We press the service button. And then we have to key in the password to get into service level. On the older control, VI service would work. On the newer control down here, it's VI expert to go through all the different service password levels. And then we would go to system configuration, push that button. And from there, we have coding level or parameter level 1. We can easily go in here and basically you would set up your general and boiler are the two areas that we would play around with in this particular control. With the devices that we have to get in to coding level a different way here, again, the same concept with the Vitodens control, OK in the menu key, OK in the menu key for the GC1B. And for coding level 1 on these controls, we've pulled down the standby and the faucet button, and that gets us into coding level 1 on those two controls. And these are the addresses we have to change. So in all the controls, we go into boiler, we adjust address 7 to whatever boiler number we need, 1, 2, 3, 4, 5, up to 8, depending on the type of boilers. And of course, the law number should coincide with that boiler number. So if you have a number 1 here, that control should also be participant number 1. If we have 2 here, this should be number 2, 3, 3, if you get my drift. It just makes it easier for a guy when he's looking at the Cascade Control that the participant number lines up with the boiler number. Otherwise, he's going to have boilers firing that he thinks shouldn't be firing, etc. The extra programming you have to make for the GC1 controls and the old WB2B control that's on the old Vitodens 200 WB2B would be this address 1 in boiler. We change it from 1 to 2, and that links the control now to a multi-cascade system. So you'd actually do that first, and then go to 7, and then go to general and adjust your participant number. So that's your setup of your basically your controls. They're ready to go at that point in time, basically for operation and control. Now we have to input the what the system needs. So as far as heating curves, so for the heating system, we have the outdoor reset curves. Information you're going to need to know. We're not going to go through a big blast of outdoor reset today because we've got lots of information I can show you. The type of heat emitters, so how cold it is in your region. So a beautiful day to kind of talk about this because all over Canada here, at least, we're in all different ranges. I'm down in the US, I'm sure is the same. Some areas you're in shorts and t-shirt, in other areas you've got 3 parkas on to make sure your nose doesn't freeze off your face. What type of heat emitters, how well that building is constructed, and of course, what's the application of that building? What are the customer's needs, what are their expectations, all those things come into play as to what I'm going to do here. That's not me, actually, I wear glasses, so that's not me. But what this contractor is going to do to set this system up correctly. If you want more information on heating curves, Mark's presentation back in September, he goes through that on multiple boiler controls. I talk about it with application and piping for condensing boilers back in October. Jody out of our US Academy office, who does a lot of presentations for the engineering community, did a fundamentals and application of outdoor reset just recently, actually, back in November. So you have some real recent information here. And like I say, 3 different guys giving you 3 different, presentations on outdoor reset. I think you should have some real good, if you went through those, have some really good information, understanding about outdoor reset and their operation. But for this one, we're just going to talk about, Viessmann uses a slope. So that's the angle of this curve. regardless of the type of control we're looking at, what that steepness of that curve is, how dramatic the heat up and cool down of the system is going to be based on the outdoor temperature here. And of course, the shift is the other one. And the shift is kind of down here in these two pictures. You can see the heating curve 1.4, the temperatures. There's 5 reference points for temperatures based on the outdoor temperature here. When I increase the shift by 10 Kelvin or 10 degrees Celsius, you see the 20 is now 30. 37 is now 47, 51, 61. You get the drift there. That's what the shift can do. So you can really manipulate your curves to customize them for your system. In the new boilers, basically to set up the heating curves, you need to hit the extended menu. You've got to program a heating curve for each heating circuit. So if you have multiple temperatures, you're going to do multiple heating curves. So select the circuit you're looking for. In this one, we're doing heating circuit 1. So actually I went backwards here. So there's your, not to confuse you guys, but here's the extended menu. Drop down, go to heating circuit 1 over here. Once we get heating circuit 1, you press heating curve, and now you've got your slope and your shift over here. And you can adjust both of those parameters, but don't forget to check the box when you're finished to make sure that it takes your new updated heating curve. And you're going to, again, do that for the other 2 heating circuits here to make sure that the curves look like what you're looking for. We also use a nominal value, a room temperature. So we don't have a sensor picking this up in the building unless you add a sensor that can do that. But the boiler control or the Cascade Control doesn't have a sensor built in that's picking up this temperature. It's a target value you're telling the control. It uses that for influence of the supply temperature. The higher the temperature that room temperature you want to maintain, the higher that supply temperature's got to be to maintain it. It's also your warm weather shutdown point. So after the temperature outside exceeds this room temperature, you can have that system basically be ignored at that point in time. And basically turn the pump off and stop trying to heat that side of the building. On the newer controls, you press your extended menu. When we're in the main menu here, you go to heating again, whichever, we're doing heating circuit 2 this time. And of course, you've got room temperature here. You adjust that room temperature, make sure you hit the check mark box, and now that's going to be your new temperature reference point. We also had a reduced room temperature, if you notice that, right next to set room temperature. We'd use that with basically with a time program. So if you want to have a setback time during the day or evening, we can do that fairly easily. So we adjust that room temperature where we want it to be, the reduced room temperature, and then we go to the heating curve, and you access the heating curve again in the extended menu into heating, your heating circuit, and of course the time program we have to enter. You'll get this little screen. You want to edit this timer. You push the little pencil here. You can use the up and down arrow keys here to make the adjustments. You can add time programs, certain on off time, and then add another one, and up to 4 of them you can add. Once you're satisfied with what you've got set there, I've set mine for 24 hours. I press the little check mark box. And now that's my new time program for Monday. If I want to copy that to all the other time programs, I just push this little icon here, and now it queues up this little area, and I can select all of these, whatever days I want. In this case, I wanted all the other days to be the same time program. Press the check mark box, and now all of the days are the same. So pretty simple to set up the timer if you need that. Moving back to this control, we're almost finished. So thank you for hanging with me. I know we're a little bit past the gate here, but with a BMS system, automation system here, controlling everything except for the boilers in this case, we may want to turn that outdoor reset function off we just talked about, because it might influence, boiler operation or turn some pumps on stuff when we don't want it to. The Cascade is getting its set points from the building management system here, whether it's through the Cascade by writing points or a 0 to 10 or a closed contact. If we want to turn off that reset curve, we'll only have one because there's only one that comes with the Cascade. You don't have any, we're not controlling the mixing valve. So it'll just be the one HC1 we have to basically take the reset function out of. First step is to reduce all those room temperature we just talked about to 3 degrees, the minimum. And then the timer program, I like to set it to either full 24 hours or flatline it, or basically no time program, but make sure both the reduced and the normal room temperature are both 3 degrees, the ones we just talked about. And then reduce your heating curve. 0.2 is the lowest and -13 shift. You'll see there's 0 degree set point now. So there's no temperature set point for outdoor reset for HC1. It's basically off. And you can either take the outdoor sensor now. Some people would put a resistor in there on the outdoor sensor port in the Cascade. Some will take the outdoor sensor and wire it and just throw it inside of the control so it reads the boiler room temperature. There's also an address 97 here, which you can adjust from 2 to 1, and effectively it turns off the outdoor sensor. So the Cascade doesn't actually even look for the contact on that 1 and 2 connection. So those are all possible basically, but in order to turn that outdoor reset function off, these are the recommended steps to get that and achieve that. On your domestic side, this is to kind of finish it off here a little bit. Domestic hot water, you've got, when we put that sensor in the control and now the Cascade is looking after your domestic hot water production, we go into the main menu by hitting the extended menu key. We hit domestic hot water. When we press that, we're going to get domestic hot water temperature set point. So you can adjust your set point. Again, plus and minus buttons, hit the check mark, and that's your new temperature. We have the time program here. And with time program on domestic, you have individual and automatic, which we didn't have with the space heating. And automatic is basically what that does is it will marry the domestic hot water time program to one of your heating circuit time programs. So you don't have to redo the domestic hot water time program over if one of those 3 heating circuits time programs is acceptable for your domestic hot water production. If it isn't, you want to go to individual and select that. And this would be the same setup as we would do for the recirc time schedule as well. It's identical. It'll give you automatic or individual, and you select what you want. And so that's what this is just identifying here, what I just talked about. So whether we want to use normal in the individual automatic, or if we want to use individual here. So clicking on individual, you're going to get this time program, exactly what we just set up with the spacing time program. So basically you get the little pencil, you want to edit it, you can make all the adjustments you want. If you want to copy the different days, you use a little icon there to copy and paste. And you would do that for the recirc pump as well. If that recirc pump is part of your system, you've wired it here, you'd have the option of doing the exact same time program configuration for the recirc pump for your system as well. So that was a look at the internals of those controls. And basically the idea there was that they're not really so different. And you go from boiler room to boiler room and these different generations of controls, the connections are very similar. The inside of the controls are very navigatable. And if you can relate to one, it's very easy to transfer the information over to the other one. The interfaces have changed quite a bit over the years here, you know, from lots of buttons here on the menus to all push button and all touchscreen control, more information on interface. But as far as the platform, really not a lot of difference between those controls, which hopefully my goal here was to basically give you some information that these are all really quite similar as far as, you know, when you move on through your day here, and you start going to these sites, that you start to identify these little bits and pieces, and hopefully the light bulb goes off there, and some of this information really will help you out moving forward. This one will be archived as well. It will be placed now in our archive, as Mark had mentioned earlier. And if Mark, are you still there with me?
Yeah, I'm still here, man.
Hey, gosh, you're hanging in there. Good man. Any questions we have, or are we?
We had 4 questions. I answered all 4, so I did really good today.
Nice. Excellent. I'm keeping you around.
Oh, good.
Yeah.
Because I don't know what I'd do if I didn't have a job.
But anyway, I hope that was useful for you guys that were listening, that listened in. Thanks for hanging in there. If you do have any other questions, you feel free to post those. We will still try to get back to you on those ones there and get them to you in email or whatever. And look forward to future presentations. We're going to go right straight through until the summer. I think this year, I think we posted up till April or maybe early April or something like that. But there's going to be another schedule coming out in the coming weeks as the percentage get our act together and send that information to Miranda and Kiana. They get that stuff out there for us. But that's enough for me. Thank you so much for joining us today. And we look forward to putting another one of these on again in the near future. Until then, signing off. Thank you.
Yeah, thanks, guys.
you.